Yeah. A-level maths, we have sequences series and we have a geometric sequence. So the sequence goes 3k plus 4, 12 minus 3k, k plus 16. Part A is to show that k satisfies this equation. So the way that we're going to do that is by using the knowledge that a geometric sequence goes up with a common ratio, meaning this times r gets us this, and this times r gets us this, which in other words means r is equal to k plus 16 over 12 minus 3k, and that same r is then equal to 12 minus 3k over 3k plus 4. Therefore, we can cross multiply here to give us 3k squared plus 4k plus 48k plus 64 is equal to, it's been a long day, 144 minus 36, 72k plus 9k squared. That's going to make a blooper reel, isn't it? Okay. This is going to be 6k squared. Basically, we're just going to make this equal to 0, hopefully, and clearly divide by 2. So that's going to be minus 124k. And for anyone watching this who's not seen the blooper reel, go find it. My social media manager is very proud of it for some reason. That will be plus 80. And then, like I said, divide by 2. So 3k squared minus 62k plus 40. Okay, so apart from that very first step, it was just GCSE maths. So understanding how geometric series works and saying that this divide this is equal to this divide this because they're both equal to r. Moving on to part 2. And I got rid of that because we have it up here. So we are told that the sequence converges, we want to find k. Well, we have a quadratic equation. To find k, I'm going to grab my calculator, go on polynomial, and just sub it in. And I found out that k is 20 and 2/3. So based off this, k is 20 and 2/3. And the reason I did that is because, let's see, part 1 and part 2 combined is 5 marks. I'm guessing that finding those two values is no more than a mark, because only one of those is going to make the sequence converge. How do we find out which one? So we're going to use the thing we did before, which gave us r, which was r is equal to 12 minus 3k over 3k plus 4, because if r is less than 1, it will converge. If r is greater than 1, it won't. So that's what we're looking for here. So when I sub in 20 for the first time, k is 20, we will get 12 minus 60 over 64, which is minus 48 over 64. That is less than 1, that will converge, and we can rewrite that as 16 is 3, and yeah, they're both divisible by 16. So this one converges. Therefore, we can assume that this one's not going to, but we are having to prove it to the examiner. So 12 minus 3 times that is 2, and then that will give us 2 plus 4, which is 6. So that's 10 over 6, which is 5/3. We should reference that here and here, by the way. So you could just draw an arrow to it like we did there. That is completely fine, as long as it's clear and obvious to the examiner. So we've now found which k converges. Part 2 is therefore, believe it or not, that is an infinity symbol. So find the sum to infinity. I'm just going to write the sum to infinity formula out, which is a over 1 minus r. We know what r is, we've got it. is minus 3/4. Do we know what A is? Not quite. We know that this is A, so we do need to sub in 20 because we can't use this one now. So if we sub in 20, we're going to get 60 plus 4, which is 64. And then we're going to have 1 minus 3/4, which is 7/4. And then stick that in our calculator. It's 256/7. So here is sequence of the series broke down. It does get a little bit more complicated than this, but this was a good 7 marker. It did come from a 2023 paper, and it was actually in the middle. So it's kind of one of those ones that you are expected to get right, and time is as important as the marks here. So get comfortable with understanding your series, get comfortable with the convergence, and hopefully all should go well. If there's any other questions like this you want us to go through, let us know in the comments. Otherwise, like and share this video.